All right, we're going to wrap up our unit on solving and with some word problems. And the nice thing about this is that it's really, in a lot of ways, just review over lots of things that we've talked about this year, right? So we've written equations, all right, before, right? We've solved equations before. So this lesson is going to pull in those different facets of things that we've talked about, all right, and incorporate them into one problem. So you're going to have to write equations. Sometimes you might have to write them in standard form. Sometimes you might have to write them in slope-intercept form or point-slope form, right? And then how we solve them, right? Now we're going to solve them with substitution or elimination, all right, versus maybe some of the other methods we've used earlier in the year. So you can see that this is our last topic for Standard 4. I can solve real-world problems using substitution elimination, right? And this is kind of the process that we're going to go through, right? So we're going to read the problem, right? As we read the problem, we're going to define the variables in words, right? So let x equal, right? Let y equal, whatever it is, right? Then we're going to write a system of equations. Remember, system of equations just means we're working with more than one equation. So it really just means write your equations, all right, from the information you get in the problem, right? Then we're going to use substitution elimination to solve, right? Okay, and we always want to show our work, right? So this is really good about process, right? So it's there for a couple of reasons, right? So one is it's communication, right? And then if you do make a mistake, we have those lines of communication we can go back and analyze and see, okay, where did the mistake? Did I rewrite something? Did I write 6 instead of 8, right? Did I make a mechanical mistake, right? Or did I have a really big conceptual mistake that we can focus on? All right, and then we want to state our solutions, all right, with appropriate labels, right, depending on the context of the problem. All right, so let me grab a couple more highlighters here, all right, so that we can go through, all right, and highlight too. And I would say if you have highlighters, pull those out, use those. You have colored pencils, you can underline, right? And that will really help you kind of break down the problem. Okay, so then there's several types of problems as we go through. So I'm not necessarily going to go in order through the lesson. So I'm going to hop around and do a handful of problems from different sections so you can see the different types of problems we're going to be working with. Okay, so we're going to be kind of like, we kind of just label this as like number problems, but here's an example, right? Last season, 2 running backs on the Broncos football team rushed for a combined total yards of 1,550 yards. One rushed 4 times as many yards as the other. How many yards were rushed by each player? All right, now sometimes the question is going to help us identify like, okay, what are our variables and what are we solving for? All right, so notice this last sentence, I'm going to highlight in purple here, right? How many yards were rushed by each player? Well, that's if we have each player and there's 2 players, there's our 2 variables, right? So I'm going to let x equal, right, the yards rushed by the first running back or the first player, all right? And then y can be the yards rushed, all right, by the second player. All right, so those are our 2 variables. That's what we're solving for, right? So the variables really represent, right, the question we're trying to answer, right? So now, what I want to do now is go back and look for information, relationships within the problem to write 2 equations. So if I'm solving for 2 variables, I have to have 2 equations. That's a fundamental rule of algebra. All right, so now let's go back to the first sentence here, right? Last season, okay, last season, which is actually like a few seasons ago now since we've written this problem, all right? Okay, last season, all right, 2 running backs on the Broncos football team rushed for a combined total of 1,550 yards. So when we think about a combined total, that means we're adding, we're accumulating those things, right? So the first player's yards plus the second player's yards equals 1,550. So there's our first, all right, x plus y equals, all right, 1,550. All right, so there's our first relationship, right? Now, if we look at the second line, right? So the purple, right, gave us this guy, right? So it gave us our variables. All right, the yellow gave us this equation right here. All right, and now one rushed for 4 times as many as the other. All right, so there's another one. So one, and that's going to be our second equation right here. One rushed for 4 times as many as the other. So, and it doesn't matter which one is x or y, it'll work out in the end. All right, so one rushed for 4 times as many as the other. So he would be 4 times as much as the other person, right? So for example, if one guy rushed for 100 yards, the other guy rushed for 400 yards, right? If one guy rushed for 200 yards, the other guy rushed for 800 yards. So this person rushed for 4 times as much as the other guy. Well, there's our equation, all right? Now, the type of equations you write will influence the method, all right, that you're going to use to solve. All right, so if I have an x equal or a y equal, I'm going to use substitution, right? If both of my equations are in standard form when I write them, then I'm going to use elimination. All right, so let the way you write the equation influence the way you solve. All right, and you'll end up in a good position to do that effectively and efficiently. So notice, since I have x equals right here, right, x equals 4y, I can substitute right in for that x in that first equation. So if I do that, I get 4y plus y equals 1,550. And then now notice I can combine like terms, right? So 5y equals 1,550. All right, and then I can divide this by 5, right? So if I grab my calculator here, all right, I don't know that math fact off the top of my head. All right, so 1,550 divided by 5, so 310. So that means our player, one of our running backs, rushed for 310 yards, right? And that's why. So right here, why, right? So rushed for 310 yards. And that's what we mean by labels, right? Rush for 310, right? So we're just going to put a little bit more specifics, all right, when we answer the question, rush for 310 yards. All right, but now notice we also have to figure out, all right, what did the other running back do? Well, we go back to x equals right here. So x equals 4 times y. All right, and then if we do that problem, all right, so 4 times 310, 1,240 yards. All right, so this rushed for 1,240 yards. All right, and there it is. Okay, so you can see that we've written equations like this before, right? Okay, we've done this type of problem before. So we're just taking all these pieces and putting it into one problem. All right, let's go ahead and flip the page here. All right, and let's go to problem 3 here. All right, and this is like a classic algebra problem. All right, so the sum of two numbers is 33. The large number is 3 more than 2 times the smaller number. What are the numbers? So once again, notice there, right? What are the numbers? Okay, and that's telling us what our variables should be, right? Okay, all right. What are the numbers? And we can even be a little bit more specific here because we see that we have the larger number, right? So when we label, let's let x be the smaller number, and we can let y be the bigger number. All right, so there we go. Sorry, I had to pause it. We had the announcements going on here. All right, so now, once again, now we have to go back. We know what our variables are. X is a small number, y is a big number, right? Now we have to go back and look for relationships that are going to create those equations. Now, once again, let's look at this first sentence here. The sum of the two numbers is 33, all right? So the sum of the numbers is 33. So sum means add them, right? So sum, so if I add the two numbers, that is 33. So x plus y is 33. There you go. All right, now the larger number. So if we look at that second one, right, there's our second relationship here, right? The larger number is 3 more than 2 times the smaller number. So the larger number is, all right, so that would be y here. I put bigger, larger, same thing. So the larger number is, now remember when we see is, that's really implying an equal sign when we write the equation. So the larger number is 3 more than. Okay, now so 3 more than means I'm going to add 3 to something. 3 more than, right? If I have 3 more dollars than you and you have $10, that means I have $13, right? Okay, so I'm going to add 3 to something. So 3 more than, I'm going to add that to something, and that something is 2 times the smaller number. So 2 times the smaller number. So 3 more than 2 times the smaller number. Now, once again, notice, all right, when I look at, right, this, okay, all right, I've now written an equation and I have an x equal or a y equal. So I'm going to say, okay, I want to use substitution because I can take this and substitute for my y right here. All right, so if I do that, x plus y, and y now is 3 plus 2x, and that equals to 33. Combine like terms, so 3x plus 3 equals 33. Get it equal to 0. So 3x minus 30 is equal to 0. 30 minus 30 is 0, so 3x equals to 30. And then 3 times 10 is 30, so x is equal to 10. So we know our smaller number is 10. All right, so now we have to go back and just say, okay, well, what's the bigger number? And I'm going to go back to y equals right here. So y equals 3 plus 2 times 10. So y equals 3 plus 20, y equals 23. All right, and notice I can check this really quick, right? The sum of the two numbers is 33. Yep, 10 plus 23. Yep, that works, right? The larger number is 3 more than 2 times the smaller number. Well, 2 times 10 is 20. 3 more than that is 23. So once you get your answer, the nice thing about these is that you should be able to go back, all right, and check those answers pretty quickly. All right, let's do one more type of problem here. Let's go down to problem 5. And these are kind of like what we call mixture problems, where we kind of have a combination of things, all right, in the problem. All right, so let's look at number 5 here. On Monday, Joe bought 10 cups of coffee and 5 donuts for his office at a cost of $16.50. It turns out that the donuts were more popular than coffee. On Tuesday, he bought 5 cups of coffee and 10 donuts for a total of $14.25. How much was each cup of coffee? All right, and I think we should have here and donut. How much was each cup of coffee and donut? All right, so have a little bit of a, I don't think I spelled donut right there, but we'll see. All right, I think donut. All right, okay, how much was each cup of coffee and each donut? Okay, all right, pardon the spelling. All right, so now once again, the question is now telling us our variables here, right? So when I think about this, right, that's going to give me my 2 variables, right? How much was each cup of coffee? So let's let X equal the cost of a cup of coffee. And let's let Y equal the cost of a donut. There we go. I think I spelled it right that time. All right, so there you go. There's our variables. That's what we're looking for. How much does each cup of coffee cost? How much does each donut cost? Now, once again, let's go back to the problem to find those relationships. Well, what did Joe do on Monday, right? So this is what he did on Monday. All right, he bought 10 cups of coffee. So if he bought 10 cups of coffee, that would be 10 times X, right? So 10 times the cost of the coffee plus 5 times the cost of the donut would equal to the total cost, which is $16.50. All right, so I bought 10 cups of coffee. I bought 5 donuts. It cost me $16.50. So there's my first, all right, equation, right, from that yellow sentence. Okay, now if I look at what he did on Tuesday, all right, he mixed it up, right? He's like, oh, I need more coffee, or I mean more donuts and less coffee, right? He bought 5 cups of coffee and 10 donuts. All right, so 5 cups of coffee, all right, would be 5x plus 10 donuts, and that would equal to $14.25. All right, there you go. Now, notice when I write this problem, right, both of the equations are now in standard form. So that's telling me, right, all right, how to solve the problem. It's giving me a really big hint. So let's use elimination. All right. Now, once again, you can eliminate either the x's or the y's. It does not matter. Okay, so I'm going to eliminate the x's, all right, just because. All right. So I'm going to look. I've got a 10 and I've got a 5. So I want to find the first number that 10 and 5 both go into. So if I count by 10s, right, 10, 20, 30, 40, 50, right? Now I'm going to count by 5s, right? 5, oh, and then I can stop right there, 10. All right, so 10 is on both lists. All right, so that's my least common multiple. Now that works out really well because notice I already have a 10x in the first equation, right? So I can just bring that down. So 10x plus 5y equals 1650. Well, if this is 10x, I want this to be negative 10x so that they will eliminate. So that means I multiply this top equation by negative 2. Right? Negative 2 times 5x is negative 10x. Negative 2 times 10y is negative 20y. All right, negative 2 times 1425 is negative 2850. All right, now I can eliminate. 10x minus 10x is 0. All right, 5y minus 20y is negative 15y. All right, and then just to be sure, I'm going to use my calculator on this fact. 1650 minus 2850 is 12. All right, or negative 12, and that's important. Okay, now to solve for y, I need to divide both sides by negative 15. So y equals, all right, so negative 12 divided by negative 15 is 0.8. Now let's think about what that means, right? 0.8. Remember, y is the cost of the donut. So if it's 0.8, that's really like 80 cents. All right, so, right, y is, so 80 cents is the cost of a donut. Put my little dollar sign there. And that seems about right. Not bad, right? Okay. All right. So now what I need to know now is the cup of coffee, right? So I have y. So I can go back and plug it in and find x. So I'm just going to use, all right, my first equation there. So 10x plus 5 times 0.8 equals to 1650. So 10x equals, and then 5 times 0.8, I think is 4. It is. All right. Oops. Plus 4 equals 1650. All right, get that equal to 0. So I'm going to subtract 1650 from both sides. And that's going to give me a 12, let's see, 1650 minus 4, right? Yeah, 1250. Minus 1250 equals a 0. All right, 10x equals, and that's going to be 1250, right? So 1250 minus 1250 is 0. And then once again, I'm going to divide by 10 here. So x equals. All right, so 1250 divided by 10 is $1.25. That's a pretty cheap cup of coffee, right? Definitely not going to get at Starbucks. All right, there you go. So then what x equals, all right, so my $1.25 is the cost of a cup of coffee. Cup of whatever. Cup of coffee. There we go. All right, so my grammar was not really strong in this video. So, all right, so there's our intro, all right, to solving word problems. All right, went a little bit long in the video. I apologize for that. All right, we'll do more of these in class tomorrow. If anything doesn't make sense, as always, highlight it, write it down, ask those questions, and we'll discuss it then. See ya.